a big bot fan, so I'm pumped for this next talk. Our next speaker is the founder of ICE Development, a Phoenix-based web and IoT company. And he's here to talk about combining web APIs with hardware and networking to build robotics with your browser. Everybody give it up for Louis Montes.
All right, thank you. Okay, I'll put my slides up if you want to look at my Twitter later. The slides are on Surge. All right, so I love JavaScript. I think probably most people in here love JavaScript, or like it well enough to use it. But not just JavaScript. I really like the community around JavaScript, especially the Nodebots community. It's been a great, just a great way to learn a whole ton of stuff. Over the last few years, I've really enjoyed participating in it. But I want to take us back here just a little bit as to how this thing started. So on September 7th, 2010, Chris Williams committed he made his first commit to the GitHub repo Node serial port. Okay, this is like the first step towards JavaScript robotics. And this is really important, and this project is still very, very important. There's over 100 contributors. It's really, really good stuff. But what I really like about it is the sort of interface that was created. So, you know, we have our typical event emitter. So when we have data events coming into a serial port connection, we're basically getting a buffer. We're getting some bytes. And it's bidirectional, so we can also send bytes back out. And this is really important for robotics in general. If we're going to be communicating between two things, it needs to be bidirectional to do anything interesting. So we're, in this case, listening for on data, but when we write, we are just sending a buffer or a uint8 array or an array. Most of these APIs will create a buffer in the end. Throughout my examples, I was very not consistent about how I was writing the bytes, so I'm just going to put them all up here. Right, what's a byte? 0 to 255, an unsigned uint8, a 0x00 to 0xff, a 0b, whatever, a bunch of bits, right? So we're going to send arrays of these things to do robotics. This is one way of doing it. Okay, so I'm sure most people here own an Arduino, even if it's just collecting dust, and you had some idea for some project that you never got to, possibly, or maybe you're already doing this. But once we had serial port, we were able to then tell our laptop over here running Node.js, hey, I'm going to send some bytes over to this Arduino. And so the first byte we usually send is 0xF9, which I think is 249. Anyways, it sends back something like, hey, I'm this version, there's some more bytes that are exchanged. We can later then say, hey, turn on pin 13. And so the hello world of robotics is usually turn on an LED, right? That's to make sure that we have communication. And then people stop right there, right? Okay, cool, I got the LED to go, and now I'm done. I've done Nodebots. But that's the beginning. That is talking to an Arduino. And that's what Node serial port enabled. The Arduino itself, though, is not, in this case, not running JavaScript. It's too small. It's really, really good at doing this pin access of turning things on and off at a certain rate, listening for sensor data. It's really, really good at that. But this is the classic Uno. It's like 32K of memory. Not enough for a JavaScript VM running NPM and pulling down a gigabyte of dependencies. So we're going to remote it this way. Now, fast forward a couple more years, Rick Waldron does his first commit to JohnnyFive, and this is huge. And this also has over 100 contributors. Awesome project. What this gives us is the ability to not think about things just in bytes, but to think about things in higher level constructs, right? Such as servo motors, LCD screens, things like that. The API is super simple, right? We just bring in JohnnyFive, create a board, and then we can blink the LED. We always got to blink an LED. That's how we do robotics, right? We blink an LED, so that's all there is to it. And this is the default, the thing that I just showed you a second ago, having a laptop connected to an Arduino, this does that. That's the default path. Okay, fast forward a couple more years. Rick puts out a blog post about how he got the Galileo, which was the Intel chip, similar to a Raspberry Pi, basically a little Linux computer, to have JohnnyFive running on it on Node, but directly on the device. And instead of sending things out to a serial port, it was talking directly to the pins. Since Node is running on the Linux that's on the device, we could talk directly to those pins to do all of the interaction. And with that abstraction of saying, I'm going to have a I/O class, or a plug-in mechanism for JohnnyFive's higher level abstractions, then other people started, a lot of people started building other I/O classes. Things like the chip, Blend Micro, Raspberry Pi, BeagleBone, a whole bunch of different ones. So now we've got JohnnyFive running all over the place on different types of hardware. And that actually spawned also, this has just been going, like I said, a really good community around this. This is this is what we do in Phoenix every July or so. This is Nodebots Day. It's actually International Nodebots Day, and there's one in probably most cities, major cities anyways. If you have a means to get to one of these things in July, go to it. It's a blast. We spend the day building a robot, potentially doing battles at the end of the day, little sumo battles, knocking each other off the platform. It's a whole day of robotics. And it started up there in the corner. We were just sort of hacking around at random toys, putting Arduinos on them, stuff like that. But it's evolved a bit. We did Wi-Fi 1 year. This last year, down here in the corner, we actually had Bluetooth bots, and some people happen to be controlling their Bluetooth Nodebots from a phone. I'll get to that in a second. Okay, so there was all kinds of creativity, too, that comes out of these Nodebots days. People are just building all sorts of things. It isn't just build a robot, make it fight. It's build a robot, maybe control it, maybe build a website that gives you buttons to interact with it, things like that. And so if we think we want to build some sort of web interactivity with our robotics, we usually default to doing this a certain way. So we'll set up a Node.js server, put JohnnyFive in it, and then maybe expose some REST commands to it, or maybe even a WebSocket, something that allows the web page to talk to that Node.js server that's talking to the pins via JohnnyFive. And this is awesome. If you haven't done that yet, do that. That's great. A lot of really, really cool projects have been built with just like that. But if you're going to use a web browser for anything, the web browsers themselves are actually really good at certain things. Certain APIs we would think we'd have to build a native application for, but then certain APIs I think are just easier to do on the web. Things like, for a perfect example is peer connection data channel. I've tried to do this in Node. I've tried to do this in other languages. This is tough. When we establish a peer-to-peer connection, we have to make a request out to the internet to say, hey, this is how to figure out how we traverse through our network. We create an offer. We then somehow have to get that offer packet to another peer. The peer then takes that offer packet. It also has to figure out how it can get back, how it can be tunneled to, gives a response back. Finally, that gets back to the first guy. And all of this is worked out in web browsers, so we don't really have to think about it. We get a simple API once we've established a handshake of yet another read and write here. When we get a message from a peer, we have a data event. If we want to just send something to that peer, it's just another write. This is being done in strings, not in uint8 arrays, but we could do the same thing. We're basically getting data between 2 points. So the web is really good at this, and if you have perhaps a Nodebot, a JohnnyFive thing on a server, and maybe you have another peer that's talking to your browser, that's talking to that server. So we can build all kinds of really interesting networks out of these things. But that's still, that isn't JohnnyFive running in the browser. That's still JohnnyFive running in Node, and then browsers talking to it. Maybe through a creative way of getting to it, but what if we want to put JohnnyFive actually in the web browser itself and not have a Node.js server that's running JohnnyFive? Should we just webpack the thing or browserify it? Sort of. What happens when you do that is the serial port, that first Node serial port doesn't just run in a web browser. Your web browser doesn't just allow you to plug a classic Arduino Uno into it. And if we try to browserify it, what's going to happen, the default path right now, is that we will create a shim for Node serial port to run on Chrome.serials API, which is fine. And we actually got a lot of mileage out of that on certain projects. but that's no longer an API that we can use to create new applications for anything other than Chrome OS. That's been relegated to Chrome packaged apps, which if you want to create a new Chrome packaged app, it's just for Chrome OS. Some of them have been grandfathered in to run on, and they're still being maintained. Chrome Serial is still being maintained for Linux, Windows, and Mac, but we're not going to create anything new that way. So that's not really the path forward. There is a web serial API that doesn't have any implementations yet. There is a spec that's out there, and that still needs a lot of work. Okay, so then what? We want to put the JohnnyFive in a browser, so we're thinking, well, maybe we should wrap it in something, right? But you might not need to do that. So that could, you might need, Electron or PhoneGap just because those are awesome projects, but you might not need them to do robotics from the browser. All right, so I love this term. It's awesome. I actually do. I like this term. I'm not trolling. But what I like about it is, that these are progressive enhancements to applications, right? So what is something that you'd like to do if you're building some sort of control panel or you're building some robotics to talk to some device, writing some software that needs to talk to, say, a Bluetooth device or anything else, you want the same things that a progressive web app has. You want the thing to run offline. You don't necessarily need an internet connection to talk to something local to you, right? Even something wireless. It doesn't make sense to have a dependency on the internet just to do something with local robotics. So PWA is perfect for that. And I'm not going to get into exactly how all of that works, other than this goes hand in hand with building robotics applications. Let's make them run offline. Let's make them instantly load, launch from the home screen, be secure, all of that. Okay, so you're saying don't use Electron for this, maybe, or Cordova. Well, then how the hell do we get a robot connected to the browser? Well, we got a few ways. I probably have an unhealthy obsession with the MIDI protocol. It's really neat in that it's really easy to use on the web. In fact, it's not just musical instruments, right? So, of course, MIDI was originally intended here, that we've got like a keyboard that we plug into. We pound on the keyboard, we get notes coming in to the computer, or perhaps we've got like something with speakers attached to it, and we send MIDI notes out to that thing, and it plays them, it synthesizes them. But we could emulate really easily a MIDI device with an Arduino. Not the classic Uno, but some of the other ones, Leonardo's, some of the new maker boards that Arduino is putting out. So there's a whole bunch of them. Some of them are really inexpensive too, that we can create a MIDI device with. And the MIDI protocol itself, let me just talk about this here for a minute. We're basically sending 3-byte commands. Now, we can step outside of that and send different types of commands, but I want to do this in a browser, and I want to do it with the least amount of resistance. So if we want to do certain types of MIDI messages that are what are called system-exclusive messages, and that's usually like to do some type of configuration, or to step outside of just I'm playing music, you're going to get a prompt that says, hey, this thing wants to use MIDI. Well, I kind of want to sneak this in first. Before I yell at the user that they need to do this thing to talk to this device, let's try to sneak bytes in. So the first byte is the command of a MIDI message, 3 bytes. And that might be turn the note on this channel, turn the note off. There's about 6 bits worth of things that we can sort of vary here. The second is which key we're hitting and the velocity, or which key was hit and the velocity if it's coming inbound. But that basically gives us 6 bits plus 7 bits plus 7 bits of room to play in. So that's 20 bits of arbitrary data if we want to think about it that way. Yeah, we're supposed to be sending notes, and that's what it was intended. But if I'm hooking up an Arduino to it that is telling the web browser it's a MIDI device, then I'm going to send to it whatever I want. So also we've got, the web API is really simple. We make a request for MIDI access. And like I said, if we're not doing anything too crazy, or the browser thinks we're not doing anything too crazy, it won't even prompt us. And we can write stuff out. Okay, so when I first started doing this robotics stuff a few years ago now, I would come across something that would show like bitwise operators and shifting and packing bits and unpacking, and I just didn't want anything to do with that. Like that did not help me to build enterprise-grade applications for whatever client, right? Like, bitwise operations is just not something that helps you, build a React front end typically, right? But it's kind of important. Like, just take the time if you haven't done that stuff before, because they're at least to me, anyways. And I might be a geek about this stuff, but when you're constrained to only having so many bits to work with, you get really creative about what you're sending out. So perhaps we can. Maybe want to light up an RGB, really colorful display grid, but we've only got 20 bits to work with. And I don't know, there's 1,000 pixels on this display, but we want to send RGB colors. Well, we know 1,000 pixels is about 10 bits. Maybe we'll put 10 of those bits over there, and that leaves us with 10 more bits to do the colors. And so maybe, we'll figure out what sort of color resolution we want to do. We'll encode the message, pretend it's a musical note. On the other side, sort of deconstruct that. And anyways, that sort of bit manipulation, it's important even if, you're building a React front end, just to know this stuff. And, several people have figured out some of the sort of bit level protocols on certain things and created some of the coolest projects that work with JohnnyFive. OLED.js, Node-LED, NodePixel. Those are things that the bitwise operations were important, and now we've got really cool APIs that are just send text to this thing, or send us an array of colors, and we get RGB LEDs, or the OLED screens, all of that. So it's worth learning that stuff if you haven't done it yet. So MIDI is a very sneaky way of doing robotics directly from a browser if you want to set up a fake MIDI device using an Arduino. But there is another way to do this. This is actually still behind a flag. It's not live on Chrome yet anyways. It's an open standard. Actually, all the things I'm talking about here are, there's at least a W3C spec, even if the implementation so far is only in Chrome and only behind a flag. Web USB is one such here. So just taking arbitrary USB things sounds really scary from a browser, right? But think about that for a minute, though, because we give apps all kinds of access. Yes, we are maybe giving USB access, but we at least know who the host is. Where with an app, we might not. We might be doing clear text communication. We don't know. But we do have some constraints here, especially with Web USB. Not only does the URL have to be secure, that's asking for permission to talk to the USB device, the user has to initiate the access, right? So we have to do a button click or something, so that the page doesn't just load and go into this mode where it's talking to USB. That's reserved for being sneaky over MIDI right now. But we also get a dialogue once we interact that will ask us, hey, do you want to give this domain this? So we've got at least 3 steps. There was a 4th step that was recently removed, and I'm very happy that it was removed. It was a little too restrictive. We were asking for a specific URL, so the device itself would say, this domain can talk to it. And that sounds great until a company that made this product that is telling you which domain to go to suddenly doesn't maintain that domain anymore or goes out of business. Now this piece of hardware is dead, so that's gone. But we still have the rest, which I think is a better model. Okay, this doesn't look as straightforward with USB, but we're still doing the same thing. We're still doing bidirectional read and writes. And what I like about this, though, I don't have to be sneaky and really creative with the bits that I'm sending here. I could just send a stream of bytes across to the thing. And there's a little bit of hard-coded stuff in here, but it's basically just telling it what type of mode we're in when we're sending the data. Is it lossy? Can we lose things if we just start slamming this thing with data? Does it have to be transactional? Does it make more sense that we're sending things in large chunks, stuff like that? But in the end, it's still, reading in results. Oh, and it's also polling. So we've got a constant loop going, asking for data in this case, as opposed to, although it's polling, we could very easily write an API on top of this that is polling in the background, but becomes an event emitter and emits data events, which is a good idea, right? If we keep it all looking like Node serial port, emit data, and then write buffer, then we can just plug this API in, right? We don't have hard interfaces in JavaScript, but as long as we have those 2 methods, we can put it into something to do JohnnyFive. Okay, so those are wired connections, MIDI, Web USB. If we want to talk to a robot wirelessly, and that's what we did at Nodebots Day last month in Phoenix, we used Bluetooth. Now, if you haven't programmed with Bluetooth recently, you might be under the impression that it's for beacons or just to do audio pairing. But it's a lot more than that. As of Bluetooth 4.0, which is already several years old now, and Bluetooth 5 was recently released, we can do a lot more than that. Bluetooth is like for arbitrary communications now. We can just describe a device. A device like Fitbit has got services, or a heart rate monitor has a service. Anything that is Bluetooth low energy can be described in services. Each one of these services could have characteristics. These characteristics are where the data lives on the service. So we can think of a characteristic as the place where we'll either subscribe to get data out of it, or maybe we'll write data to it. But because we're able to do that, since we can sort of generically say, hey, I'm going to make a Bluetooth device, and I'm going to have that device give out services of whatever I want to define, I can, without having to like define a standard for a device that operates this way, I could just make a thing and then use a browser to talk to it in the way that I want, which is really nice. That said, most of the robotics around Bluetooth so far is using a single characteristic called Nordic UART, which is basically just saying write bytes to this and then read bytes, read notification bytes. So it's really just another serial stream, another write data, on data, do the thing. There's some problems here though. Typically a packet is about 20 bytes. This is pretty low bandwidth. There's also what I found is some latency in that if we write to it too fast, we'll lose things. So we might have to buffer things up. So there's some workarounds. But if we're just telling a robot, hey, here's 3 bytes for you to move a servo arm to 90 degrees, something like that, perfect. There's already a bunch of projects around this. There is some supported hardware. BLE Serial is a way to use the same interface that Node Serial Port uses, so that we can just plug that in and then use JohnnyFive directly. So if we want to do this stuff through Node.js, we use Noble. Noble was written by Sandeep Mistry. It's bindings for Bluetooth low energy. And the cool thing is, like, just use Noble anyways, because if you use Noble in Node.js, you've got all this Bluetooth low energy interaction, but there is a shim, so if you browserify Noble, under the hood, it's going to be using Web Bluetooth. So it'll do the Web Bluetooth binding, so we can basically write things for Noble, and then just browserify them or Webpack them, and it'll use the Web Bluetooth API. So this is what Noble looks like, and again, very similar to Serial Port. On data, we have a callback, and there is a little bit more, because what we could do is we could actually, with Bluetooth, ask for, hey, give me the value of this characteristic, or we could subscribe to a notification. So anytime that characteristic changes, it'll send me data. So that'll be more like a stream coming at us. We're using the same function call to read in Noble, but it gives us a flag whether or not that was meant as a notification or just a response to me saying, hey, I need to read some data. And write actually can take a flag as well that we may or may not want this thing to be a transaction, like something that we say, I need to get a response to that write. That's going to be slower, but it may or may not matter. So you might want to just send data without requesting a response. The characteristic, though, that you're writing to has to support whether or not you can write to it with requesting a response or not. Okay, this one's super new, and the spec, of course, says that it's like a volatile API that that's subject to change. But Nearfield Communications, everybody's phone has got this. Apple Pay, Google Pay, all of these things are using NFC. And of course, there has to be a web API on top of this. And this is actually like a super simple API. Of course, it's behind a flag. And I don't know if this hit the origin trial yet, where we can work with Google to say, hey, just allow this for this domain. I don't think so, but anyways, most of this sort of thing is going to be behind a flag called Platform Experimental Features. So if you go into Chrome flags, disable or enable Platform Experimental Features. So the Navigator object has an NFC, which has a push that we send data to. So that's basically just emitting, right? It's an NFC radio that's just emitting. So if somebody has an NFC reader, we could use a browser to tell it, hey, send whatever text we want. I think that's great. The corollary to that is we can tell a browser to watch for NFC messages. Right, so we can tell it, hey, this thing is emitting, go read that, basically. So we're getting both our read-write off of these APIs as well. Okay, so I've got a few minutes to do a demo, which is good. Doing a hardware demo is the dumbest possible thing you could do, so I'm going to do that. I've gotten a little bit better about this. I've got a Arduino. This is a cheap knockoff Pro Micro. That is a Tesla's accelerometer. So we can get XYZ, accelerometer or alpha, beta, gamma. Everybody loves QR codes, so I'm going to throw a QR code in here. What I like about these, though, is that, okay, so a QR code is, you can describe data inside the QR code, right? So when we're doing internet-connected devices or little Nodebots or whatever, they should have an ID so that they can be addressed so that a network can get to them. Well, if the thing is addressed, it's probably in the form of a UUID, right? Or 16 bytes, 2 to the 168th, which is 32 hex characters, right? Typically when you see these UUIDs, except people put dashes in them to make them 36 characters. And when you make them 36 characters, all of a sudden you cross this threshold where the QR code's like way bigger, and it's like, harder to read because it's so much bigger. So anyways, if you're going to do any UUIDs plus QR codes, take the dashes out. They never should have been there to begin with, and then you get a better QR code. All right. But why am I having a QR code here? Because, well, not only do I want to do the robotics from a browser, but there's some more APIs that we can use. And we've got the coolest toy box, like Lego pieces that we can just build stuff on top of. And especially if you trip any of those flags in Chrome or Firefox to enable the stuff that'll crash the browser in the middle of a demo, you can still, you got just so much more stuff to play with. Okay, the last thing is RoboHash has these really cool images. I sort of stitched them together so that if we give any arbitrary text, like say a UUID or something in a QR code, instead of showing an ugly QR code, let's show a cute robot face, right? Okay, so a little bit more demo setup here. All right, what I'm going to do is create I'm going to start with a video element. Let's just throw a video element in page. Let's throw a canvas on top of that, okay? So we'll put the Z index of the video behind. We'll put the canvas up front. Why would we do that? Well, if we want to draw on top of a video, which is what I want to do here, you want to put the video behind there, have the video just running in real time, and put, how about 3JS in front of that? With 3JS, you can turn the background off, put alpha to true, and set its color to 0. And so now we have a transparent 3D in front of it. And then why did I do a QR code? Because let's take that QR code and use yet another API that's behind a flag in Chrome, the shape detection API. We can do QR codes, we can do face detection, we can do text recognition. QR codes are particularly cool because we can get the text out of the QR code, but we could also get the 4 points around it. So it'll give us the location of something on the screen. I'm going to do this in a web worker as well, so that this demo is already slow enough, but I want to have that thing at least going in the background, because text detection on a full screen cameras or QR code is a little bit taxing, so we'll have that running in a worker thread. We'll post the content back up. We'll take those 4 points, and I just learned this stuff too, by the way, so I'm pretending to be an expert on this, but there's an algorithm called posit, which says take these 4 points. If you know the size of the thing, you can figure out where it's at in 3D space. Based on its pitch, you can say what its angle is and stuff like that. So, all of that said, let's see, how do I get out of here? Oh, cool. All right. So that's me. That's weird. All right. Okay, so I've got that video in the background. I've got the canvas in the front. And like I said, I've failed at demos before. And one of the reasons is because I didn't put the things in a little plastic box. And if you put something in a plastic box, it's less likely to ground out. So I connected the QR code, the QR code's on the front, accelerometer, little Arduino, sending MIDI signals based on the accelerometer. And what do we get? We got some augmented reality, right? So this is not using any other like toolkit. This is just stuff that's built into a browser now, right? Shape detection, MIDI, QR code scanning, we got positioning. So I'm reading the accelerometer data. I think the next step to this would be actually to use the accelerometer data to better center it, because I think my algorithm's off just a little bit. Anyways, the code for this stuff is all is up there on GitHub. And I'll put it on Twitter as well. These knobs don't do anything. I was going to use them as potentiometers, and I figured it'd be more fun to use accelerometer data. The other thing is that we might default to using a little screen on an Arduino or a Raspberry Pi or something, but we all carry screens in our pockets. So we could just instead maybe throw a QR code on the thing, find out its ID, somehow get that data back over to our device, and then do our own heads-up display on the screens that we already have. So anyways, we got a really cool toy box and stuff, and that is, I didn't even have that much time. I'm a minute over, so there we go. All right.